So I'll present hopes and difficulties with using control protocols in production. So I'm going to share some ideas about what mitigations might exist by default, what are the ones which are tractable to build right now, and what are the kinds of roadblocks that one might face when trying to design control protocols, what are the constraints that are binding decisions that are being made right now. And I'll take question at the end, and also there will be an officer right after the talk. So, I will share personal views. They do not represent the views of my employer. I'm not claiming that Anthropic is or isn't doing any of the things described here. Cool. So I'll describe what I think the default trajectory is for what are the sorts of mitigations people will use in practice. I'll describe examples of control mitigations, which I think are doable today, which are tractable to build today. Some hopes and difficulties for actually getting them deployed, at least internally, at AI companies, and how constraints might change when AIs become more powerful. So first, I'll point out that some mitigations already exist, which would make the lives of misaligned AIs somewhat more difficult today. So first, during AI training, if you use reinforcement learning, it will train away some low-reward behavior. Developers will look at transcripts. During testing, developers will also look at what AIs are saying. Maybe also check that the performance is as good as you might expect. These are not perfect mitigations. A good enough schemer might just recognize which prompts are obviously training or obviously pre-deployment testing. But these at least gives you some assurances against AIs which are misaligned but not very clever. And also you have things which happen in deployments. So for example, when AIs are writing codes, usually, at least today, humans will look at the code that AIs write before pushing it in production. There will be also static tests, static analysis and tests to make it hard to slip by subtle mistakes. And once it actually executes, then there are classic security things like detection and response, which might catch some of the more egregious things that AIs might do, for example, attempts at exfiltrating weights from servers. But things might change in the future. So I expect that as time goes on, by the most likely trajectory is the amount of quality weighted AI labor to go up by a massive amount, far exceeding the amount of human labor available. And so while today you can just check the code that AIs wrote and probably avoid many sorts of problems that might arise, I expect that in the future it might look a bit more let's see what AI assistants are up to. And this makes it more difficult to check every single thing that AIs are doing. And afterwards, crazy thing might happen, but I'll mostly focus on this intermediate regime where AI labor are massively speeding up safety critical work, AI alignment research, cyber defense, and these other things. And so once you get in this middle region where AIs are being used as extremely productive assistant, I expect that we'll keep most of the existing safety measures except the PR review one, because this one requires lots of human labor. But we'll keep probably most of the default security. I expect that humans will still try to keep track of what AIs are doing, so a bit like executives at in regular companies try to keep track of what their employees are doing, though most of it might just look like humans asking the AIs directly what they're up to. I expect that to prevent mistakes, things might look increasingly like AIs checking their own work. And I'm unsure if things will involve more or less sandboxing. So maybe AIs will be given, will be put in stranger sandboxes so that they can do very large trajectories without mistakes, risking causing very security critical issues. But maybe also there will be less sandboxing if people manage to drive the rate of mistakes sufficiently low that just giving them more affordances is worth it. But again, the situation is still relatively risky. I think two important risks are the risk of rogue internal deployments. That is, AIs that manage to run in ways which aren't monitored, using maybe affordances which developers did not intend to give to AIs. So for example, if AIs try to manage to get root access to the data center, they might be able to run scripts which run themselves a lot more without any any form of monitoring, doing like research into like how they might cause even bigger problems to happen. And this might not be trivial to prevent because this might look not that different from regular research workloads. And also AIs might like, and humans won't be able to like look at every single piece of code that AIs are writing. I'm also afraid that AIs might sabotage safety critical work. So if they're doing most of the work, it will probably give them lots of opportunities to like insert certain bugs that like make certain promising research project look like they're not working after all, or might allow them also to like oversell research that doesn't work right. And also depending on what exactly the shape of AI capabilities look like, I'm somewhat worried that AIs might succeed at like self-exfiltration, or like manipulate or persuade some humans into doing things which are like extremely against their best interests, or even like other things. So how can we like defend a bit better against these risks, and what are the sorts of control mitigations which might be doable to implement today? So by control mitigations, just things that directly help with safety and that work even if AIs are initially misaligned and that are tractable today. There are lots of things which are useful to improve safety. This one is like doing research, doing better evals, doing policy stuff. This one is mostly about actually implementing very basic measures. I think people should do other things. So the default state is specifically for coding agents. I think this is what things will look like by default. So you have a loop where like you sample a new generation from a language model, you execute it, you sample again. Sometimes the human users will give instruction to these AI agents. Sometimes they will look at actions before executing them. And I claim that there are ways to modify this like default states to like inject some control mitigations. I think a default thing that is probably good to do and that I think is tractable is to have human users report to some auditing team actions which are suspicious, so that we can like learn more about the weird AI behaviors. Some of these weird behaviors might be related to like very concerning misalignment concern, especially as AIs become more powerful. Another easy place to intervene is to add some API monitoring. That is, right at the like output of your inference server, you just like maybe run monitor right here, and also you log the traffic. And this also allows your auditing team to like notice if some very worrying things are going on. And the third class of thing, of interventions, which I think are very tractable, is adding within scaffold monitoring. So before an action is executed, an LLM monitor looks at it. And then once you get a score for like how suspicious it looks, you can either like block it and just ask the human user what it wants to do. You can resample it. So even without asking the human user, you just like resample a new action, which hopefully will be better. Or you like tell the language model, whoa, what you was about to do was like very problematic for this reason. Can you suggest a different action? Or you can like report it directly to the auditing team if it was like very suspicious. Okay, I think this is starting to be tractable because we are starting to get like standardized APIs and scaffolds. And so this means that we have like actual software objects that we can start to modify to add control mitigations. And I think that in addition to the preparation benefits of adding these mitigations today, there are also some near-term benefits of using these sorts of interventions. And in particular, my current favorite near-term benefits is that models are sometimes a bit too eager to solve problems and will make mistakes and will like go like a bit beyond what user intended. So for example, like this tweet says that like Claude 3.7 Sonnet needs its handhelds as a leash to stop it from building an entire sort of service business when you ask it to create a database. So this mistake is not too bad, but there are like slightly worse things that like Claude Code could do. And I claim that if you had better reporting and API monitoring, you could notice these issues appearing earlier. And if you had within scaffold monitoring, you could preventing from like causing issues with like this sort of like eagerness to solve problem. There are like other classic near-term benefits you could get from control like mitigations, like preventing LLM misuse, which is a good motivation to like start implementing good ways of doing API monitoring, and security against humans. which is like mostly not applicable for the mitigation I've talked about here, but which I think are like a promising reason in general to monitor what people are doing on your data centers. Okay, so what are the roadblocks when trying to build these sorts of control mitigations in practice? I think one of the main roadblocks is like the productivity. So there is like the productivity of people actually using the scaffolds and using the API, which might be reduced if you have too many false positives, which are like blocking some of what they're trying to do, and also which increase the latency. If you run a monitor before executing an action, this might increase the latency of like when you're like actually doing things, which might like slow down the execution of the agent loop, but might also like slow down usage for like more interactive work. You might also lower the productivity of people just building the scaffolds by like adding code bloat to the code base. I think these are not like massive costs. These are like doable and probably will become more tractable as like people worry more and more about misalignments. But today, I think it's plausible that like effort might be better spent elsewhere. So if you're like willing to bid for some time of like other people in an AI company, maybe you should instead have like engineers help with like safety projects, or maybe you should like make sure that everyone in the company understands the risks of AIs and maybe like improve the culture of the organization. There are also other things you can do to limitate these costs. Things like first focusing on mitigations that run asynchronously, don't like actually block the actions, do like simple deployments first. And so to the extent that some of you want to build control techniques that might be deployed very soon, I think it's a good prompt to think about what are like simple ways for things to be implemented that don't increase code bloat too much and that like have an impact which is not too big on the productivity. Another natural roadblock that many of you have already thought about is the price. The naive price is just like monitoring needs compute. Even if you use like a very cheap monitor that only costs 10% of the regular monitor, if you deploy it on like a full external traffic, this might be like hundreds of millions of dollars of like compute spent, at least like at the OpenAI scale. And also like it might reduce revenue and have a price in indirect ways. So for example, a classic worry is if you use monitoring, especially if you have a human reviews afterwards, this will reduce the privacy of the conversations with users. And to the extent that some users don't like that, this might reduce revenue indirectly. And again, I don't think these costs are like completely like major blockers for anything happening forever, but I think that these resources right now might be better spent on other things. So for example, like AI companies can fund fellowships or expensive science experiments. And also there are ways to like get slightly around this roadblock for now by, for example, doing internal deployments first and doing like cheap versions of the scaffolds first. And the third roadblock is security. I think this one won't get better over time. So the basic concern is if you have human monitoring, this means humans look at the traffic, and if the traffic contains sensitive information, so think about like algorithmic secrets at labs, or if you're you're helping governments, maybe it contains state secrets, then it means these humans might learn these secrets and might weaken what like is called compartmentalization, which is like only small teams have access to these secrets. Another kind of security concern is if you rely too much, if you use LM monitoring and you advertise it as being very good, and this means people use their own judgment less than just like mash the approve button. I think this can actually like reduce like AI safety on nets. So you have to be like somewhat careful about this. I think for now, the like easy fix is you just like avoid deploying control mitigation to sensitive internal deployments, but this is definitely not a viable solution. Like I want in the future that like AI control, like I want AI control to be deployed even for sensitive internal deployments. And so I'm keen to see like future control work thinking how to get around these sorts of constraints. Okay, very quick note on project with near-term benefits. I think having project which have near-term benefits has like benefits but also costs. So if it's close enough, you can get real-world experience, understand a bit better what are the real constraints. Also, you get direct preparation for like actually building these tools. But if it's too far, it can be distracting. And there are also like indirect benefits and costs. For example, it helps the AI company which might be hosting the project, which might mean you get more resources to like work on that project. It also means that they get more resource, which depending how much you're like the AI company you're working at might be like benefits or not. And also it helps other AI companies to be safer, but maybe there are like some compensation effects where if you give them some tools to be safer, they just cut corners on other things, which means that like it speeds up timeline with like relatively small net, like additional net safety. Cool. So the constraint I've described so far are the constraints that like I'm seeing right now. I think things might still like change in significant ways as AIs become more powerful. First, I think AIs will become more powerful over time. And additionally, people will want to give these like very powerful and scary AIs like lots of affordances, like maybe more computes, access to their emails, access to like money. And I claim that in the situation on the right, as opposed to the situation on the left, which is closer to the current situation, users will want more guarantees about like what will the AI do and not do. I also claim that responsible AI companies which care about misalignment will like be more careful with these AIs and these AIs, and probably will be like more willing to spend more to prevent bad things from happening. The main reason why like the tractability of control mitigations might not improve as much is because the models might look more trustworthy. Like if you have a smarter AI, it might also be like more situationally aware and more like able to distinguish what is like an action which is like an obvious mistake from the action that the user actually intends. And so I expect overall that like concerns around compute and pricing will go down as like people become more keen to get higher guarantees. But just because like these two concerns go down doesn't mean you have like other costs which become more important. For example, one thing that is relatively cheap to have right now is have a human in the loop. When you block an action, show it to an actual human. And maybe also like don't give access to AIs, don't give lots of computes and emails and money to AIs. I think this might become a bigger bottleneck in the future as AIs become more useful and as like the amount of AI labor grows. I also expect that like security and secrecy concerns will go up because I expect that like people will want to use AIs for more stuff, including things which are like very sensitive. And also there are like miscellaneous ways in which like the future is weird. I expect that if you have lots of AI labor, the scaffold and the AI actions might become much more confusing. Like you could imagine, like AI labs are like right now relatively small and it's not like impossible to keep track of everything that's going on. But if you're like speeding up everything by a factor of 20 because AIs are doing a huge amount of labor, I think it might be harder for humans trying to understand if a given action was bad or not. Like why was this action taken? What was the bigger project that it was part of? And therefore, like things might be more confusing, which might make like auditing AI actions harder. Other things that might be weird, maybe trusted models might become more expensive than untrusted ones. Because untrusted models might be able to do things to make their own inference way cheaper, and you don't really trust their distillation process or like the things that makes models cheaper process. And so you don't want to apply to your untrusted models. And so this means that like the price of your untrusted models might go down extremely fast as you apply like untrusted AI labor to make untrusted AIs cheaper in a way that don't like straightforwardly transfers to trusted models. Also, you might have like changes in architectures that makes AIs harder to monitor. Also, you might have like continuous deployments where instead of having like distinct like training and evaluation and deployment phase, you might get like continuous training and continuous evaluation and continuous deployments. I think some of these are like preventable if they are like extremely bad, but like there might be like significant costs associated with like avoiding some of these things. And so I expect that like current work on control protocols might not be like directly applicable in the future because the future might be a weird place. I still think it's worth doing because I think there will be some applicability. I also expect that like current AI control work helps us understand in the future how we will do it, how we will adapt to new constraints, both for like future humans doing this work, but also future AIs. Okay, so to conclude, some takeaways. I think it's important to take into account existing default mitigations, um, both to like avoid the threats which are like most likely to be dealt with with the default control mitigations, and also like to build more realistic and interesting control settings. I think it's like we're starting to get at an exciting time where like control mitigation can be deployed today, subsidized by preventing mistakes from AIs. So I'm excited to see like various AI labs and maybe startups build things like better reporting, better API monitoring within scaffold monitoring that leads to actions like blocking, resampling, or reporting AI actions. And maybe there are like other exciting opportunities to be like taking advantage of. And for people doing like more researchy style work, I'm interested in people taking into account constraints which are like relatively foreseeable. Uh, Many existing work taking into account some constraints like the costs of running monitors, but I'm interested in like taking into account specifically maybe like directly user productivity, maybe the ease of implementation and maintenance, at least to the extent that they want to implement them right now, even though in the future probably there will be like more willingness to implement more complicated things. Taking into account compute requirements, taking into account user privacy and secrecy, taking into account security implications. And I also encourage people doing like control research to like think of potential weird future constraints that we might face. And if any of them seems particularly likely, maybe build control protocols which work despite these constraints. Thank you very much. Okay, so we have time, I think 3 minutes maybe, or maybe a bit more for questions. And then in another room, there will be like an office hour where people are welcome to come if they want to chat more about these questions and about like other things related to AI control.
Are you optimistic about like uh, being able to build like privacy preserving kind of monitoring, uh, basically monitoring techniques that would like allow monitoring to be applied widely, maybe like using ideas like from other fields where like uh, privacy preservation is important?
I don't know exactly which ideas from other fields you're referring to. Uh, the sort of things that might be applied from other fields is like if you have automated algorithms, for like monitoring, you can just like apply this automated algorithm without having any human look at it. So for example, if you have a very, very good monitor, you can just have this monitor run and you never look at the most suspicious thing it finds. I think this is like a somewhat sad situation. I think at some point I want a human to look at it such that like if the AI did something actually extremely spooky, you're able to like raise the alarm. I think the way you do that, one of the ways of dealing with this challenge, um, is maybe to uh, have the users themselves or like someone in like a compartmentalization group actually review the most suspicious actions. And if your monitors are good enough, maybe you're like it's actually worth people's time to actually look at the most suspicious actions. Uh, Also, maybe there are like some control protocols which don't rely on this reporting of the most suspicious actions. So, for example, like if you're afraid of sandbagging, the most weirdest action won't look terribly suspicious. They will just look slightly weaker than they would otherwise be. So maybe in other fields of or in for certain like threat models, you will be able to do things which are like more privacy preserving. So it's not like I think it won't be very easy.
I'm just curious, when you do production monitoring, how do you handle streaming APIs?
Okay, so there are like multiple ways of doing this. One way that people have experimented with for misuse is using streaming classifiers. Obviously, these are like have some flaws because like sometimes it's much easier to notice that something was suspicious when you see like the whole block as opposed to a prefix. Uh, I think if you're so one thing you can do is like for some suspicious thing you just disable streaming, and then a last solution is um, you just wait for the full streaming response to come in, and then you do like if your like call to the monitor lives on the front end, which obviously is not ideal, you can first get the streaming response back, and then before acting on it, for example, by executing the action, you just send that back to the monitor once like the action has fully streamed in.
Yeah. So basically, like that would just introduce latency into your API, then, though.
Oh yeah, yeah.
Yeah. Okay. So it's a latency cost when you do streaming.
Yes.
So for the graph where it's slightly more ahead and people are monitoring their own agents doing things with like money and this, that, the other, where do you think it's most likely the monitoring is going to come from? If like part of it relies on the model, part of it might be around actions related to the scaffolding. Where do you think it might? Who do you think in like the value chain might provide that?
Sorry, let me try to rephrase the question. I'm not trying to state it.
Sure.
Is the question like what is being monitored, or is it-
Yeah, I guess thinking who do you think's most likely to be the person providing the monitoring to the user? Do you think it will come from the
Oh yeah.
like the developers of the models or like the intermediary layers?
And for internal deployments, probably it will be like the AI companies themselves. For external deployments, I think it will depend a little bit. I think it will often be the people building the scaffolds, since I expect it to be like slightly sensitive to it. For example, like I could see, for example, like Cursor trying to like build these sorts of things in their own scaffolds if there was demand for it. Though, yeah, maybe the incentives are not like exactly aligned here. I'm not sure. I can also imagine like either like AI labs or like third parties like providing these directly as services. One advantage of having the AI labs do it themselves is that if they're the one who are like owning the absence of catastrophic risk, probably it makes most sense for like them to like ensure that these sorts of like defensive measures are always used. Though obviously it depends a little bit what the like threat models are.
Yeah.
For example, I could imagine that like if you're doing a deployment in a government agency, and the AI lab doesn't have a lot of transparency to what the government agency is doing, that it will be the like government agencies themselves who will be responsible for ensuring the safety of the deployment.